Okay, so let's go over your homework questions from Thursday evening. So first on page 622, number 9, says a sample of tritium is produced, 1 gram of tritium is produced. What will be the mass of the tritium remaining after 24.6 years? So you have to flip back in your book and see that the half-life of tritium is 12.3 years. And so to figure out the number of half-lives, it's just delta T over 1 half-life. So 24.6 years over 12.3 years. So it's 2 half-lives. So then we do MF is equal to MI over 2 to the N. So MF is equal to, originally it was 1 gram over 2 to the 2, or 4. So how much is left? 1/4 of a gram, or 0.25 of a gram. Okay, question 10 says isotope of neptunium, if only I could see the subscripts, 238 has a half-life of 2 days, and you start off with 4 grams, and it wants to know how much will be left from a Monday to a week from the following Tuesday. So that's 8 days. So if it has a half-life of 2 days and there's 8 days, the number delta T over T 1/2, 8 days over 2 days, that's 4 half-lives. Then if you flip back in your book and you find, oh no, we don't need it, sorry, I lied, because the question actually wants to know what will be, they had already given us a half-life. So we're doing MF is equal to MI over 2 to the N. And this time it tells us 4 grams over 2 to the 4. 2 to the 4 is 2, 4, 8, 16. So 4 grams over 16. In other words, MF is equal to 1/4 again. Totally a coincidence. The next one is polonium 210. And polonium 210 decays. So it says its activity is 2 times 10 to the 6 decays per second. So this time, instead of giving us a mass, they give us what they call an activity. So you could just call that AI. Doesn't matter if it's MI, AI, it's going to be the same in the equation, just the M's will turn to A's. And it wants to know what'll be its activity, AF, on June 1st. Hardest part in this question is figuring out how many days between September 1st and June 1st. So we know there's, it might be easiest to do 365 and a quarter, I guess, technically, days. I might leave the quarter off, though, because where does the quarter come? So 365, and then you're missing 3 months. You're missing June, which is 30 days. You're missing July, which is 31 days. And you're missing August, which has 31 days, rather than add up the other way. So you have 273 days. So that's the total time. So delta T is equal to 273 days. And if you flip back to the chart, and it's polonium 210, you'll see it has a half-life of 138 days. And so we can do number of half-lives is equal to delta T over T 1/2. So 273 over, I think it was 138, they just said. Yeah. And so divided by 138, you get 1.978. So be good if I was on the screen. So 1.978 half-lives with some other decimals that I'll leave in my calculator. And so then we can say activity final is equal to activity initial over 2 to the n. So activity final is equal to 2 times 10 to the 6 decays per second over 2 to the 1.978, etc. So activity final equals, so then on your calculator, because you probably can't do 2 to the n in your head when n is 1.78978, so you go 2 and you hit this little button right here, which is y to the, whoops, I don't know what my calculator just did. Recall, I think I stored that. So we have this, and that is what you're going to then do by 2 to the 6th. And you should get, put that in scientific notation, second function 4. Okay, why isn't my calculator doing anything? 5.0759 to the 5th. So you get 5.0759 times 10 to the 5th decays per second. Alright. Number 12. Tritium was once used in some watches to produce a fluorescent glow so the watch could be read in the dark. If the brightness of the glow is proportional to the activity of the tritium, what would be the brightness of the watch in comparison to its original brightness when the watch is 6 years old? Okay, so the time is 6 years. We already said the half-life, we had looked it up in question number 9, the half-life of tritium is 12.3 years. So we can find the number of half-lives. Again, delta t over t 1/2. And so 6 years over 12.3 years. So n is equal to 6 divided by 12.3, and you get 0.4878. 0.4878. And so this time it's actually asking for the ratio. So it says activities and the fluorescent glow or brightness are proportional. So activity final is equal to activity initial over 2 to the n. But it's asking about the ratio, right? The comparison of its original, what would be the brightness of the watch in comparison to its original brightness? So brightness of the watch in comparison to its original brightness. They're really looking for the final over the initial, that ratio. And that's really equal to 1 over 2 to the n. And so we had 2 to the n was 0.4878. And so you want to do 1 divided by 2, and then your y to the x button. And you should get something close to a quarter, because this is the n is pretty close to a 2. So it's going to be 0.253796. Okay? And that's the ratio. So that's the first set of questions. Flipping to the back of the chapter, I then asked you to do questions 12 through 17. We're going to run out of time here in a minute. 12 says, in an accident in a research laboratory, a radioactive isotope with a half-life of 3 days is spilt. As a result, radiation is 8 times the permissible amount. So for this one, number 12, it's saying